So let me firstly correct Miha. It's not so much about Elasticsearch than it is about fine-tuning the Elasticsearch with the help of the evolution algorithm. So UF is the product of DLabs. It stands for Business of Fashion. It's the London-based startup, and it's one of the 3 big projects in DLabs. Biggest in the term of traction that we get and the team size that works on it. So it's a big project. This is it. Most of the guys that work on this project are really happy because they always get to look at the nice ladies. Okay. The infrastructure is, well, it's basically, it started as a WordPress blog site. And then for something, they use Symfony and obviously MySQL as database. And then Mongo, Redis, Elasticsearch, Ruby, HHVM, Go. It's all running on Amazon, and you name it, we got it. So my role on this project was to work on search engine on Elasticsearch. There is quite an there was architectural mistake made there. So all the PHP stuff is connecting to the Rails app, which is then connecting to the Elasticsearch, which is not the best, I think. It's pretty crappy. But me as a Rails guy and a guy who was interested in Elasticsearch got the job to maintain this shit. So the fashion folks, this is really, as I said, the business of fashion. They're quite, I don't know, they're not tech people. They really don't, they know what they want, but they cannot express it in a way that computer person could understand it, or to write a formula about it, or I don't know. And they they have it's only the search among the blog posts. I don't know, there's 10,000 blog posts, but they want it to be perfect. So I want this article higher than this one. I want stuff like that. And they want it right away. So there's no compromises in there. So this was my challenge. Make search work in such a way that relevant results will be found. So the relevant results are relevant to them. I didn't understand how to make stuff just as they want it. It should be a bit fuzzy. You know what fuzzy search is? Yeah? Like, okay, I can make a typo here and there and the results will be okay in any way. They have, I don't know, 5 years old articles which shouldn't be displayed in the first page of the results. We had this, as stated here, items that are shared more. This means that we had data about how much each article was retweeted, or how much times it was liked on Facebook or stuff like that. But we didn't know how much impact it should have in reality. So these are some search queries and the results that we should get. So Thomas Deula is, I don't know, a fashion guy, I guess. He's mentioned in a body of a really old article, and he should be first. Like when we search for Thomas Deula, it should be the article where he's mentioned should be first in our result set. Then we have tweets and tribes. This was a really interesting one because we have this tweets, which is quite common term, and of course end word. We can get rid of it by using stop words, but also it's quite an old article, and it doesn't account with the rule that old articles shouldn't be on the top. And we have Dolce Gabbana, of course. It's a quite common term that is in the articles, but still what was with this one? Oh, still, there was, I don't know, some important news from 211 which should be on the top of the search results. Okay. I don't know, because the fashion folks that I was talking about before, they just feel it. As I said, we cannot put this in some mathematical function. So as I said, we used Elasticsearch. We have, well, first about Elasticsearch, it is search engine, do you know it? Who knows Elasticsearch? It is promoted as working out of the box, and it is to some extent, but when you want to fine-tune it, or when you want to do something like this, you get really fucked up, because the documentation is quite bad. You have the syntax, you have, they say a few lines about it. Okay, fuzzy search will do this and this, but you don't have any examples on the real data what will happen if you use fuzzy search or match search or parse search. Those are all different kinds of search that you can do. Then you have boosting options. You can boost your results based on field. Let's say title is always more important than the body. The category is always more important than the body and stuff like that. You can boost on a search type. I used all of these searches that are displayed here, and I say, okay, fuzzy search has a boost 1, match search, which means that we match whole word, is boost 2 times, and parse search is boost even more. Then you have script score. That means that you can write a script how some scores are more important than other ones. I don't know if you can see this, but here is like, if this article is in category 1, then you should boost it by 0.2, which means down boosting. Then we have decay function. It is explained on the next slide. And again, you have the the score mode, which means if you have more script scores, or more script scores, how will they be? What we'll do with the results that we get from multiple script scores? Let's say if we have 5 scripts that have scores, we can take an average of this score, we can multiply them, we can take max or anything. So I had no idea how to resolve this problem. Okay, decay function. As I said, one of the functions was decay function. That's in Elasticsearch. It's used for let's say you have these articles that have timestamp on it. Then you can say when the article is getting older, please put the score on it down, because if we have 5 years old article, it's not that important to us. So we can make it. You have several options how quick Decay is doing its stuff. You have exponential, Gauss or linear functions. So you can say each day the importance of the article is coming down for 1% or something like that. So I wasn't even sure which of these to use. So this is my parameter set for the search. Can you see this? No, I will not. So in the first group, there is the stuff that I was talking before, how each scoring function is behaving in a relationship to the other scoring function. Then the second section is about which kind of search to use. The third section is about this decaying stuff that I was showing before. The fourth section is still about it. And okay, the fifth section is how much boost factor has each of the search way that we do. The fifth section is about how much boost does each element, each field in document get. Let's say title is boosted like 8, summary is boosted by 4, and so on. And the last section is because they have some categories like daily, how's it called? It's daily report or something, and news should be down boosted because they have also these deep articles about some fashion guys and stuff, which are obviously more important. So this thing was not doing well. We had really, I don't know, at least once per week, the guy came to me, the team lead of this team that is doing business of fashion, and said, okay, here's a search term that isn't doing well. So, okay, and I fixed a thing for this search term, but then the other ones that came before just fell off. They wasn't even in the first page of the results. So you can see this, I guess. So as I said, straight search is here. Like this is just straight search. We don't do anything with it. We don't have any modification, any scoring functions, anything. So for Tom Adeyula, which was one of the cases, it works just fine. It works the best. It's the first result. It's everything. Everything is cool. But if we search for Dolce & Gabbana, then we get really, I don't know, 2 or 3 pages of irrelevant results which are old and stuff, because of the way the Elasticsearch scores stuff. But if I turned on then decay by time, the scoring, the less scoring of few categories and stuff, then I got really good results on Dolce & Gabbana, really good results. But then, because of fuzzy kicked in, Tom Adeyula was in 77th place, I guess, which wasn't that good. So I was doing this juggling with all these parameters, and it was just crazy. I did it once per week for a whole day and doing a search, and okay, fixing parameter and doing a search, and it was just not great. So I said to myself, I'm a programmer. I do with this machine, which should work for me, not me doing this stuff. So I could automate this thing. I could just try all the possible combinations and get the best one out of it. But as you have seen the parameters list. It's just, it would take years, I guess. So I decided, I've read before about evolution programming and stuff, to do it in this way, with use of evolution. So you must know Douglas Adams. Here's a quote, you cannot see it. Here's the Charles Darwin, and of course Richard Dawkins. The Selfish Gene is a really good book and you should read it. It's before the God delusion and stuff like that, so it's quite a quality book. Please read it. So, devolution algorithm. It's all stated here. Create a random population, run fitness test, choose best subjects, create new population from best subjects, and then run fitness test on them, and to redo this stuff until you're quite satisfied. Genome for the single element of population was my list of attributes for the search. So this was it. I choose this. Okay. Vocabulary, we'll skip this, I guess. So genome is a set of rules that determines how each subject will behave. In my case, this is the set of search parameters. Population are just all the subject. Subject is a single object. In my case, Elasticsearch with this setting hash. And the fitness function is a function that determines how good each subject is. So how good results do we get from Elasticsearch? So this was my genome. This is the creating of random population. For the boost mode, I can have sum, average, max, minimum. So I choose the random one, and the score mode also. And if I should split query, which is one thing, minimal score that we should use was random and stuff like that. So this was my initial population. Nobody talked about it. So it was bad. When the first search came, it was really bad. It was a random set of rules. These are my fitness functions. Can you see it? Guess not. Yeah? Okay, this is, as I said, this guy came to me each week and said, okay, for this case, this doesn't work. So we together defined search queries and the results that should be first. So then we put all this in this fitness function. So when I did a search, I had, I don't know, 50 of these functions to just to see how each search was doing, if it's all right. As you can see here, tweets and tribes, that was one of the problems on the slide before, should be as high as it can be. So I divided one by the place that it was on. So if it was on the second place, it had a score of 0.5. If it was on the first place, it had score 1, and so on. So this is a little bit different. This one is this article should be before this article. These are article titles. So this one should be before this article. So if it is, we get, he gets 1 score or something. So I did, I don't know, population of 1,000, run this script, and then took the 10 best and create a new population out of it. The genome mating was done like this. So I had 2 arrays. I just randomly choose from 10 subjects. I choose 2 subjects and just randomly use the attribute from each of it. I don't know, if subject 1 had average and subject 2 had max, I choose average, for example. If subject 1 had 14 and subject 2 had 18, I chose 18 on the random, of course. So I choose random.
Why did you decide to take just 10 best results?
Well, by trial and error.
Because you can lose a lot of diversity if you take just the best.
Yeah, of course, but if you would do it with the whole population, I don't know, as I said, I did it also, and the scores didn't went up as fast as it could. So yeah, but it happened, it happened, I called them inbred. So after a while doing this, we got, I don't know, thousands of generations, we got the same result. There was no new best of it. And when I stopped the script and took a look at the genome that was produced at the moment, they were all the same. Maybe some parameter really unimportant was different in all of them, so it was not doing well. So I introduced the mutations, which means from the this is again the procedure of breeding two different genomes. So sometimes depends on my mutation rate. I choose the random value for a parameter for a gene fraction. These are these blue ones. So average didn't come from this one, didn't come from this one. It was randomly. This was okay. The problem number 2 was this is the curve from let's say generations and score. So this means best score. Best scores, of course, goes up fast at the beginning and then really slow towards the end. So here was the thing that I was talking about. I was trying this with whole possible set of I don't know, the best subject size, the whole population size, and I don't know. I just choose 10. So the other thing was if many generations has passed from the last best score, I increased the mutation rate. So this was happening. More of these were blue, let's say. If that didn't help, I pushed the last best known genome into the set of 10. And if that didn't help, I just created a new random generation of the such objects. This is the end. So okay, I was running this on 16-core Amazon instance for I guess 2 days. I get some set of rules. I wasn't sure if it's good enough. I just knew that I spent my company's money on my own experiment. So I got this result. I don't know enough about Elasticsearch that I would know is it good enough. If it isn't, I did a few queries by myself. I said, I guess it's good enough, and deployed it to production. So, and the next day in the morning, this guy came to me. So he said, "Okay, I've got a new search query for you. So this should be on the first place of the search, and this should be in the second." This was completely new query, not in our yeah, not in our test in the fitness function. So we did the search and it came first. And this all happened about a year ago, and I hadn't heard any problems with it yet. So everything works which is quite surprising to me. Because I think my believing that if we do this stuff like this will work for every other cases, I think this believing was quite naive, but somehow, I don't know, somehow it worked. So.
But that's the general for this experiment, yeah.
Yeah, I don't know.
I also don't believe in evolution.
I'm not sure here. We even got this is completely side effect and nothing to do with this. We even get the search times like 10 times less. I don't know, if before was, I don't know, 500 milliseconds, now it's 50 milliseconds. Which is nice, I guess, it's side effect. But we could also put the response time in these fitness functions and to be sure for search queries to be faster. I don't know, is there anything else to go? Thank you. Was it? Was it 25 minutes? Wasn't it?
Any questions?
Any questions? Did you at least understand what I was talking about? Yeah.
Can you go back a little bit? I will stop you. Maybe. But there's some Ruby code. Yeah, here. Does this, the left function, like press more time?
Yep.
Does it always find both of these places?
Yeah.
How come?
Magic.
I mean, how come both of these are always results? Isn't it weird?
No,
You're
because
just changing the parameters.
Yeah, because-
parameters only affect the order of results.
Oh, just the order.
yeah, because I always parse the whole set of the results. So and if maybe it could happen, but it didn't, which is a good point here.
But then why do you have it on the right one? Because then that one should also always match, right?
Yeah. Yeah.
I was wondering because then you have division by 0, right?
Yeah, you're completely right. Yeah, but well, it didn't stop, I guess.
So I guess you know,
Yeah.
that's good.
Yeah.
Just for fun. Yeah. Thanks.
Any more questions? No, please. Okay. Oh, yeah. Another maybe really technical thing. I was running this with JRuby, with I don't know, 20, 16 threads, I guess, which really helps us because running the Ruby out of the box was really slow, and it didn't use all the processing power that we had. So yeah, that was cool. Also the threading was heavily used there, and Jan helped me in a big way.
Okay.
Yeah.